All right, folks, we're going to be looking at force and motion diagrams today. So let's just get started. Diagrams. All right, so in force and motion diagrams, we're always looking at all the forces or all the motion things that are acting on the object. So, example, if I have a rock, okay, and I drop a rock, right, something's going to be pulling it down. We all know that that's gravity, okay? So gravity is pulling it down. Maybe there's a little bit of air resistance pushing up on the rock. So, we draw a little arrow, air resistance. And that's pretty much it. That's all that's going on with the object. So this is what we call a force diagram. So these are the force diagram. And let's do a motion diagram. So let's say that we have a car driving, okay? So don't laugh at my car. Okay? My car is going in that direction, okay? So that direction, and it has a velocity of whatever it is, initial velocity. And he's going to accelerate too. So he's going to have a positive acceleration. So he's running away in that direction, okay? So this would be like a motion diagram. This would be a force diagram. Okay, we're going to look at some of these situations and how they're important because we need to draw out something if we have a word problem. So here we go. So if I have, let's say the running man. So the moving man, in the yesterday that you guys did. So say you have a man at the house. And his wife and child say, hey, we want a Christmas tree. Can you go cut down the Christmas tree? Well, the Christmas tree was over here. So we need to go cut down the Christmas tree. So he's going to go cut down the Christmas tree. So this is the direction that he's going to go. Okay, maybe he has an initial velocity of something. Okay, he noticed that it's starting to get dark, right? Maybe he needs to hurry it up. So he's going to give himself a little acceleration to speed up and get there. So we have an acceleration and a velocity. Well, we can also label it as distance. Right? The distance he travels over time, right? So from here to here, he's traveling a certain distance. And we'll call that x. So this would be a free body diagram for motion, for the moving man. And what that shows us is that we have direction of velocity, we have direction of acceleration, we have a distance that he's going to be traveling. So we can get some information. Now we can give values for all these things, but I'm not going to have you do that on the activity. What I'm going to have you do is I'm going to have you compare different sides of a cart. So the cart is in the middle. You have a guy on one side, you have a guy on the other side. And the big question is, what's going to happen to the cart when they both pull? So let's look at one of those situations. So you're going to go to the simulator that I have set up for you. And you're going to click on the simulation. This one works inside your browser. It does not make you go outside your browser. Now, there are different ones. There's net force, there's motion, friction, acceleration. You can't see it up here, but there's 3 other ones. You're just going to work with net force today. Okay, we can work with motion tomorrow, friction, acceleration not so much, but friction and motion another day. So we're looking at net force. So we have these people. Okay, we have a large man, a middle, and maybe two children or something. Okay, so we have them pulling on the cart. All right, and we know that if we put one of those little people on both sides, we know that the cart's not going to go anywhere. Okay, but let's reset and see if we put a big man on one side and a little child on the other side, what's going to happen. Okay, And so you have some forces, right? We talked about free diagrams. So we have some forces already pulling one direction versus the other. Right is very small. Left is very large. So this is our diagram. This is our free body diagram for forces. And then we can also know that the motion is probably going to end up going that direction, right? The guy is going to pull the little kid with no problems. Here it goes. So you can see that the object is starting to move this direction. Okay? Now, I can pause, return. Let's try something crazy, just to be fun. Let's put everyone on this side. Okay, and let's put one guy on this side. What do you think is going to happen? That's probably right. It's going to go this way rapidly. So it's moving that way a lot faster than it did last time. Because this force over here is a much, much greater. All right. So this is your lab activity. So I want you to do your lab activity. Play with this first, and then do your lab activity that involves these guys.